Hi, my name is Long Vu. I'm a DevOps at Uranus, and today we're gonna talk about automated deployment for better return on investment. So first, a few words about the PAVICS project, the project we're gonna use to demonstrate the return on investment. So first, PAVICS is meant to be, the goal of PAVICS is to provide climate science as a service, basically a one-stop shop, barrier included, turnkey solution to perform science analysis. Well, I say science, but climate analysis, sorry. And we now have climate and also hydrology in the stack. So we want to encourage interdisciplinary collaboration. So if you are an expert in one area and you want to run analysis in another area, you don't have to implement yourself the algorithm in the other area because it's already implemented, already coded, already debugged for you. It's also meant to help lower the barrier of entry, the overhead to perform science analysis, because everything is ready to go in the cloud on our server. All you need is your internet connection and your internet browser. So the project started in 2016. We are now 4 organizations contributing to the project: Uranus, CRIM, U of T, and PKIC. We have fundings over the years from Canary, ECCC, CEDA, and DAX. So when you get on our homepage, there's a clear description of what the platform provides, and also what the platform can do for you. So you have end-to-end tutorial showing you the code for an end-to-end workflow from data analysis, from data access, all the way to visualization. So back to return on investment. So basically, when you order online, you are really getting the worth of your money only when your order arrives. If you are a car dealer, you are getting back your money only when your car is sold. So basically, all the time and energy spent fixing bugs, implement feature, is you as a developer, you only get back this return on investment when your end user actually can use it, which means it is deployed in productions. So a package or a bill that is not deployed is basically like a car unsold, still in the dealership parking lot, taking up space. Remember that to your end user, the bug is still not fixed unless it is deployed. The feature do not exist yet unless it is also deployed and in production. So what are the advantages? The biggest one is you can deploy much more frequently. So you have a much more, a faster feedback loop. You have a faster recovery. If there is a problem in production, you can deploy a fix faster. You can have faster prototyping. You can close the loop much faster with your user. And oh yeah, and this basically allows you to go toward the next step, which is continuous delivery. So again, smaller change that go into production means less surprise, and less surprise means less stress. So PAVICS, we try to deploy nightly. So basically each PR that is merged is being deployed by its own, unless there's 2 PR merged in the same day. So if something goes wrong for us, it's very easy for us to know what went in that broke something, and we can also revert if we need to easily. So now specific advantage for the devs. So basically, as a dev, you are now the boss of your own projects. The success of your projects now do not depend on someone else performing the deployment for you. You basically gain deployment access without having to ask for it. And you control what goes out and when by the timing of your PR. Also advantage for the organization. The organization gains resilience. A lot more people can perform the same task, so you increase the burst factor of the organization, which is the number of developers that need to be hit by a bus to kill a project. You also gain traceability because it's an automated process with logs. It's not someone done manually and might or might not have kept the logs, and make it accessible to other people. There's a few requirements for this to be a success. First is you need rigorous code review. Because if you are fast to ship feature and bug fix, you can also be fast to ship regressions and new bugs. So you need a good code review to catch all that. You also need a good comprehensive testing integration test suite to also catch all those bugs. And you need reproducible deployment environment so you can test with confidence that your test environment is really similar to prod. So if it pass in your staging environment, it will pass in prod. So PAVICS, we actually test using real user end-to-end workflow using the tutorial notebooks that we deploy on our environment. So whatever notebook that user use to learn about a system, we actually use that to test. So we are testing with the mindset of the end user. For reproducible environment, we also use Vagrant to spin up a complete VM. The stack is based on Docker, so very helpful for reproducible environment. And our staging server actually checks for deployment every 5 minutes. So as soon as something is merged, it's being deployed on the staging, and developer can immediately assert if something is wrong or if it works correctly. So how we did it? How does our auto deploy works? It's actually pretty simple and pretty generic to all the projects as well. So I'm confident that you can take this talk and the code that I will show later to apply to your projects as well. We basically have a scheduler that will trigger this pipeline. So first we detect if there are new commits on all the repos, not just one. We support multiple repos. If at least one repo has new commits on the same branch, basically the branch you want to deploy, the branch is checked out right now, the process continue. We stop the server, and it's important to stop before pulling a new code so that you are using the actual code that is compatible with the current state. Then we do the pull for all the repo, and we deploy the new code. So PAVICS is made of actually 3 platforms because we want it to be pluggable. So there is a generic repo, and then we have our Uranus override, which basically allows you to also deploy our platform and have your own override without having to commit to the platform itself. So go back to the pluggable idea. And also, we also follow infrastructure as code, which means we are also committing our configuration, which is host name, password, and various cron jobs scheduler. So these items will differ between our staging and our prod, but everything else is identical. It goes back to having a reliable staging environment because we actually source control the config. So we know we are deploying the same thing on our staging environment. But not only that, we are also deploying other jobs. So NCML here is a neat thing that allows us to provide different views on the data. Typically, NetCDF, you can have like 1 file per day. So which means the end user will have to deal with multiple files, a lot of files, hundreds of files. So with NCML, we can aggregate all those files onto one single file, one single link that the end user can deal with. So it's much simpler. And via NCML, we can also correct metadata that is wrong so that we don't have to change the actual file, original source file, which then will change the checksum, and then will make it harder, if not impossible, for us to verify data integrity. So that's NCML. So that's one repo for all the NCML that we deploy on our thread server. We also have test data that is made of 2 repos on our test server. We also have the homepage which is deployed. So the homepage you see is being auto-deployed. If someone makes an improvement, new addition, it's live very quickly. When you log into our Jupyter lab environment, all the tutorial notebooks from different components and from the homepage are already deployed into your personal Jupyter environment. You don't have to go copy paste code. You don't have to go and download and upload yourself manually the various tutorial. It's It's all there for you, and it's auto deploy live. Someone fix a typo, add a new notebook, or fix a bug in the notebook, it's live for you. We also have another job that deploy JEPS forecast, which is JEPS is global ensemble prediction system from the from Environment Canada. So all those extra jobs, let me count. So the primary platform is 3 repos, NCML is 1, test data is 2, homepage 1. The tutorial notebooks are coming from 4 different repos. JEPS forecast is from another repo. So wait, 4, 9, so 12 repos. So imagine that if we did not have auto deploy, then this will be a big overhead for the person doing deployment manually. So basically, auto deploy, it's been out. The auto deploy we did is in production for more than a year, and it's already paying for itself, and it will be paying forward many times forward as we add more different auto deploy jobs to the stack. Here's my contact. Again, the PAVICS link. And for deployment, you see there are 2 repos, which is the generic one and the Uranos custom override. Also the repo for our testing, our notebook testing, where we actually test using the notebook. The first one, the Jenkins config, is the configuration to spin up a pre-configured Jenkins pre-configured to run the second repo, which is the actual jobs that we collect all the notebooks and run them on the Jupyter environment that we deploy. So basically, we are testing using the same Jupyter environment that the end user will use. So we are sure that the runtime environment is able to run the tutorial notebook that we provide when you log in. So there will be no surprise when you log in and execute all the tutorial notebooks. Also, I have provided here different links to, let's say you want to reuse our auto deploy mechanism. You have links here to different files, direct file that would interest you. So you don't have to look through the repo for which file you need to extract. And also example how we use it. So test data deployment, the homepage deployment, the trigger auto script, which is the JEPS forecast. That's it for my presentation. Thank you for your time, and I wish you have a great conference. Thank you.